In Chapter 10, Section 4, number 22, we're trying to find the perimeter of the right triangle WXY, given that the radius of the circle is 4 and that segment WY has a length of 20. So the first thing that I want to mark up on my diagram is that segment WY has a length of 20, and also that the radius of that inscribed circle is 4. Alright, now based on this, the solution to this is also going to use the two tangent segment theorem, or the two tangent theorem. And it kind of goes like this. We know that this segment here is congruent to that segment there because they're both going to be tangent to the circle and they originate from an external point. And as the same would be with these segments here as well. Not only that, we also have the segments coming out of the right triangle. And so we have these three pairs of tangent segments that will all be congruent among themselves. Now, since the radius is 4, we can say with certainty that that segment with the 3 bars on it is going to be 4 units long. Now, we don't know about the other one, but what we can do with that is to come up with a system of equations here, and that is if we call this y and this y here, we know that they have to be congruent. And if we call this segment down here x and this segment down here x, then we're going to be able to come up with a system of equations. The first equation being that x plus y is equal to 20, and the second equation being x plus 4 squared using the Pythagorean theorem plus y plus 4 squared is going to be 20 squared, which is 400. So probably the strategy to use here would be to use the substitution method of solving a system of equations. And that would be to state that y is equal to 20 minus x. So we're simply going to replace that, and we would have 20 minus x plus 4 in place of y plus 4, and that would give us x plus 4 quantity squared plus 24 minus x quantity squared is equal to 400. So what we need to do at this point is to multiply everything out, and on the left side that would give us x squared plus 8x plus 16, and 24 squared is 576, and then 24 times negative x double is going to be negative 48x plus x squared is equal to 400. And we're going to combine things and bring everything to the same side. So we have x squares. There will be 2 of them. 2x squares next are x's. We have positive 8x and negative 48x. So that's going to give us a negative 40x. Then we have 576 plus 16, then minus 400. So 576 is 586, 592 minus 400 is going to give a positive 192. And next thing we would do is factor out any common factors. So we factor out a 2. That leaves us with x squared minus 20x and that should be plus 96 is equal to 0. So we're looking for pairs of numbers that multiply to give positive 96 and add to give negative 20. So we'll do that over on the side. That would be 1 times 96, 2 times 48, 3 times 32. Now since the sum of these two numbers is negative but their product is positive, then we have to have both of these as being negative. So negative 4 and negative 24 would be another pair, but that adds up to negative 28. Then we'd have negative 6 and negative 16. And finally negative 8 and negative 12. So that's going to be the pair that does the trick for us. So we end up with 2 times x minus 8 times x minus 12, and that would give us x equals 8 or x equals 12. So it doesn't really matter which we use for x. If we had x equals 8, then plugging it back into our first equation with x being 8, y would be 12. Obviously, if x is 12, then y would be 8. So it doesn't matter which we called x and which we call y. The two segments are 8, 12, and 20, which makes this a 3, 4, 5 triangle. So the sides, the 8 side, if x were equal to 8, then the x side would be 12. The y side would be 12 plus 4 would be 16. And obviously the hypotenuse we know already is 20. So it would be 3, 4, 5. It would be 4 times 3, 4 times 4, and 4 times 5. And the perimeter would then be 48. And that's going to do it for this problem here. So this turned out to be an algebra problem, but also still very much using this two tangent theorem that we learned in Chapter 10, Section 4.